Welcome to week 3 of the RoboChargers CAD class. We are going to start this week off the same way we're going to start every week off. We're going to go to our folder in the CAD class and we're going to create a week 3 document. Okay, so this week we're going to continue what we talked about last week, which was sketches, which are the kind of 2D drawings that we use to base everything off of. And then once we're finished with sketches, we're going to go over a few more of the features up here that are similar to the extrude tool we talked about last week, but a few more of the tools that you're going to need to model parts. We're not going to cover all of these tools in the CAD class up here. Some of this stuff is relatively advanced that you're not really going to use for FRC or FTC. And once you learn a couple of the tools and you're kind of familiar with how the dialogue works, it's pretty easy to just mess around with these tools and figure out what they do. There's also really good docs. Like if you just search online, a lot of the docs for some of these features are explanatory enough that you'll be able to figure it out. So what we're going to do, we're going to create a sketch here. I'm going to hide these planes like I usually do. So last week we talked about some of the constraints that you use, and we talked about one constraint in particular, which was the dimension constraint, which basically just defines the size of an object, constrains the size of an object, or the distance between two objects. Now, I create a circle here, added a dimension to it. The dimension acts like a logical rule, and that's kind of the important thing that you need to keep in mind, as you're working with these constraints, is that they are mathematical and logical rules that are applied to your sketch. And anytime you change something in the sketch, like you change a dimension, right? Onshape has to recalculate all of the geometry, and as it's recalculating, it's taking into account these rules that you are creating to control how the sketch is kind of rebuilt. So in this sketch that I've created here, we've already have a few constraints. So one of the constraints that's not so easy to see, but is relatively important, is there is what is called a coincident constraint between the center point of the circle and the origin, which is this weird kind of circle here. So the origin is just kind of a point floating in space at 0, 0, 0 coordinates, and it's always there, and you attach things to it. Last week we talked about attaching stuff to the origin. If I hover over the middle point, and really any piece of geometry, but in this case the middle point, you'll see this little box, this little icon or glyph or whatever that appears, and it's got this little icon that tells you what type of constraint this is. So anytime you hover over a piece of geometry, little icons will appear that show what constraints that piece of geometry is involved in. Now, a lot of constraints involve two pieces of geometry, and we'll talk about what that looks like here in a second. But a lot of constraints use two pieces of geometry, and so this icon will appear if you hover over either one of the pieces of geometry that are involved in that constraint. Let's talk about a few different types of constraints and how you add them. Now, the constraints box is up here, and you can click this drop-down arrow and they'll all appear. I actually have my screen, the size of elements on my screen turned up so they show up better in the video. So if people are watching this on like a phone or something, some of these icons and stuff are stand a chance of being visible. If you're on like a 1080p or higher screen, usually more icons show up on this bar. These constraints usually just line up, but because of the settings I've got set up for this video, this is a drop down. So that's something to be aware of just in general in Onshape. A lot of the stuff will just be it'll auto resize, it'll collapse, it'll expand depending on how big your screen is and how your layout is set up. So let's create a piece of geometry here. We can attach some constraints to. Just gonna create a line out here. I'm not gonna no dimension. I'm not attaching the endpoints to everything. It's just a floating line in space, and I can drag it around. I can move the endpoints, whatever. Um, okay, so let's talk about the simplest constraint, I suppose, that we kind of just talked about here, a coincident constraint. Coincident is pretty much just a fancy word that just means attach. It has, some slightly different mathematical connotations, but basically it's just attach one thing to another. Typically, the simplest way to understand it is if I have 2 points, right? I have the origin point, for example, and the center point of the circle, just attach those 2 points to each other. Just kind of merge them into one point. So that means that the center point of the circle is attached to the origin point. I can also, if I want to, attach the endpoint of a line to the origin point. Now, there's 2 ways to create a coincident constraint. Coincident constraints are so core to sketch geometry that you can just attach things by clicking and dragging. Now, the thing is to understand that when you click and drag and attach 2 objects together, it is placing a coincident constraint for you. There is no difference between placing a coincident constraint manually using this little tool up here or by just clicking and dragging. So the easiest way to do it is I can just click this endpoint, click and drag, and then you can see when I get close, this little like rectangle appears around it. That means that it's about to attach. And if I let go of my mouse button, it attaches. Now you'll notice I can't move this line off of that point. I can still move this endpoint around because it's not attached to anything, but this endpoint is now attached to the origin. And if I hover over it, you'll notice a couple more of these icons appear. Now I've got so much stuff on top of each other; these are a little bit hard to see. But you can see if I hover over this left one, you can see it's highlighting the circle. How the circle just kind of shows up this weird like yellowish green color. That means that this coincident is involved with the circle. So in this case, we know that this is the coincident between the center point of the circle and the origin. This other one, if we hover over it, highlights the circle and the line. Now, actually, there's some weirdness going on here because we've got multiple points layered on top of each other. So what we actually did when we clicked and dragged was we attached the line endpoint to the circle center point. We didn't actually attach it to the origin. There's kind of some weirdness there, where there's some ambiguity in terms of what clicking and dragging will actually do. But you can see here that the line is involved in this coincident constraint, and basically we know that this is the one that we just created. Now, let's say I did that by accident and I didn't want to create that constraint. You can delete these by just right-clicking on the icon in question and hit delete sketch entity. Now you'll notice if I click and drag the line, now it separates from the circle and I can move it around again. So that's how you delete a constraint. You will do that pretty frequently, especially if you're working in complicated sketches. It's important to understand how to kind of change, to undo these things and kind of break sketches apart and reattach them using different constraints if you need to change stuff. Okay, so that's the simplest case of coincident where you're attaching one point to another. There's also another case where you can attach an endpoint to a line or a curve, right, which is an arc, a circle, or a line, right? Those are all curves, basically. Curve is kind of a generic term for line-shaped things, curves as opposed to points. So you can do a coincident constraint between an endpoint and a shape, a curve. So we can click and drag, click and hover over, you can see it highlights. You can see the little icon appears beside my mouse that shows that it's about to create a coincident constraint, and the circle highlights. If I let go, it'll attach. You can see there's this coincident constraint here. So that's pretty cool. Let's undo that, and let's do it a different way. So let's actually click the tool. So if we click the coincident tool, we can click the endpoint and then click the circle, and it's the same thing. And we can keep clicking things. So you can see the tool stays active, and if I'm done with the tool, I can hit escape. And so you can see now we can drag this line around, but it doesn't actually come off the circle. You'll notice a little graphical thing. If I move it really quickly, the line looks like it comes off the circle. That is just the calculation that's updating the sketch can't keep up with how fast I'm moving my mouse, and that's just a a result of like the server side stuff, right? It has to send data to the server has to recalculate the sketch and send it back, and so there's like a tiny little bit of lag there. But if I move this and let go, if I move it really fast and let go, you can see it snaps back to the circle. So that's just something to be aware of, is that just because it looks like the line's coming off the circle, it's not actually doing it. It's just waiting on the recalculation to finish. All right, so let's keep going here. I'm gonna demonstrate one other feature of the coincident constraint, and then I want to move on. So I can take a line and another line and just create them here. That one was really short for some reason. So I can obviously attach this endpoint of this line to this other line, right? Just like I did for the circle. That's fine, but I'm going to undo that. Another feature of the coincident constraint is that you can make two lines lie on the same line. So the thing you got to keep in mind is that a line, even though this here is like has a length to it, mathematically speaking, this line continues to infinity, right? Which you might be familiar with that from school, from math class and creating graphs and slope intercept formula and all of that. Lines are kind of these virtual shapes that just extend to infinity. And so I can take this line and I can use the coincident constraint to attach the endpoint to this line. But you'll notice, if I drag the lines like this, I'm going to kind of get these out of the way. They're overlapping with the circle, and everything's kind of freaking out. Okay, you'll notice if I could attach these two lines to each other like this, that's great. But I can grab this endpoint and drag it right off the end of the line, and there's this gap between, so you're like, well, this endpoint's not attached to this line anymore. But what this endpoint is actually attached to is the kind of like virtual infinite line. And so if I move this down, you can see the other line moves. Like they're attached to each other, but they're not actually touching each other in terms of the line segments. They're just lying on this line that extends to infinity. So that's an important thing to keep in mind, is that you can attach two lines to each other even if they're not physically touching on the screen. I'm going to delete this constraint, and then if I have two lines here, also this inferred another constraint that I didn't want. There's lots of things it'll constrain things automatically for you, so you got to be careful. So what I can also do is I can use the coincident constraint to attach two line segments to each other, not line points, not like endpoints, but like the actual lines themselves. Now they're overlapping here, so that's a little bit weird, but I can click and drag them out. You'll notice they stay lined up with each other, right? I can't move them left or right in relation to each other. They follow each other around, but I can obviously slide them along the line that they share. So they're kind of sharing a line here. That's called collinear. A lot of other CAD programs have a separate collinear constraint, but Onshape combines the collinear constraint along with the coincident constraint, which in my opinion is a nice, clean way to do it. I'm going to delete these lines just to declutter. All right, so let's move on to some other shapes here. So constraints that apply to specific shapes. So let's talk about tangent first. So what tangent does, and you can kind of see from the icon, honestly, it kind of shows what it is. It basically just means a line can only touch a circle at one point, right? So like this line, kind of is like kind of going into the circle, right? If I continued this line to infinity, it would also contact the circle over here, right? So thinking about the infinite line, this line would actually contact this circle at 2 points, right? It would cut through the circle. But if I want this line to kind of smoothly transition into the circle, I can take the tangent constraint, click on the line, click on the circle, and now you'll notice it's like nicely smooth. It's only contacting the circle. If I continued this line to infinity, it wouldn't contact the circle in any other places. And if I undo that real quick, I just wanted to note, you can click these in any order. So I can click the circle first and then the line. It's not important to do what order, right? It doesn't matter. Okay, so let's do this. All right, so let's talk about a really easy one. Let's talk about the horizontal and vertical constraint. I'm just going to talk about the horizontal constraint, but the vertical constraint works exactly like horizontal. So if I click the horizontal constraint and just click on a line, it just makes the line horizontal, right? That's super cool, right? That's easy. There's another use for this line though, this coincident, this constraint. I don't know why I keep forgetting that word, but I do. So let's create a line over here. And let's place a horizontal constraint between the endpoint of this line and the origin. Now what that does is that keeps this thing lined up horizontal to that point, right? I can move it left and right, but it's basically constrained to a horizontal line that is even with, this point. And I can do the same thing for vertical, right? Like if I wanna create a vertical line, a vertical constraint between this point and this point, right? Now they're lined up to each other vertically. So you can either just click horizontal or vertical onto a line, and it'll just make that line horizontal or vertical, or you can attach 2 points to each other so that they're lined up, when they're not touching. So that's one you'll use a lot. Let's talk about equal for a second. So if I have two shapes, lines, arcs, circles, and I want them to be the same size, I can use the equals constraint. Now, I need to specify what I mean by size. I specifically mean length for lines and diameter or radius for circles and arcs. So if I have a good way to demonstrate this is a circle, right? If I put a circle over here, and I want this circle to be the same size as this circle, I click the equals constraint, click the two circles, and they'll be the same size, right? So that's great. I'm gonna kind of finish out the sketch so I can actually extrude it. So we're gonna use a coincident constraint, attach these two circles to each other. Gonna use a tangent constraint to make them tangent to each other. We're going to make a line between the two. You'll notice when I create a horizontal line, you see that little icon on my screen, it automatically creates a horizontal constraint. Hey, but maybe I don't want that, right? Maybe I hover over the line, find the horizontal constraint and delete it, right? And maybe I want this line to now be tangent, so I'll make it tangent to the circle. And maybe I want this line to be horizontal, the endpoint of this line to be horizontal from the origin there. And then I can go in and create a dimension and dimension the two, center points here. Or actually, something I didn't demonstrate last week that I probably should demonstrate. You can dimension the sides of curves. Right, so if I click the outsides of these circles, it'll kind of grab the outsides. So maybe I'll make that 8 inches. Now, you'll see I've got an extra curve in here, which normally isn't okay, but I'm going to demonstrate one other quick tool here for sketches. There's this cut or trim tool. If I click this tool and I click on a line segment or I click on a segment of a curve that's like broken by two other curves, like I can click on this segment, it'll just delete it, right? You don't need to do that, and I would recommend, unless there's some very good reason why you're doing that, you shouldn't do that because it creates some weird geometry in your sketches. Like this circle is now an arc technically, and so then when you go back to edit the sketch, you might expect it to be a circle, but it's going to act like an arc. So if I delete this dimension and I go in and recreate the dimension, now it's a radius dimension instead of diameter, which might not be what you're expecting. So it's just don't trim geometry that you don't need to, but sometimes you need to trim geometry, and that's how you do it. All right, let's finish this sketch here. All right, I'm gonna just extrude this shape out. Hit the extrude button, select these two regions. This is the region why you would trim, right? Because it combines the regions. Like I had to take this in 2 clicks. If I had trimmed this circle, it would be 1 click. I can actually just demonstrate that. I can just trim, done, right? Extrude. It's just one region, right? Okay, so let's 1 inch is fine. All right, so let's talk about another part modeling feature that is pretty useful. This is called, in most CAD software, this is called work geometry or reference geometry. There's a variety of different types of reference geometry in most CAD software. However, in Onshape, really the only one that's relevant is a plane. There's also a mate connector, which we might go into later in the CAD class. We probably will at some point, but it'll be in a project most likely. I'll explain how they work. But in the case of Onshape, if you're used to other CAD software, you might be expecting to see an axis or a point or something like that. A mate connector actually takes the roles of those. It's kind of a point and an axis combined. Like I said, I'll explain more about mate connectors later when we talk about assemblies. But the plane is kind of an irreplaceable one, and so Onshape has a separate plane. I suppose technically you could use a mate connector as a plane mathematically, but they don't for some reason. So plane is a very useful one. So let's say I'm in a part studio, right? So I'm creating multiple parts here. Like, let's say I'm designing a robot mechanism, and I've got this part over here for whatever reason, and then I've got I need a gap between these two parts, and then I want to create a sketch and extrude a part with a gap between them, right? I can't. There's nothing I can create a sketch on, right? I can't create a sketch on the default planes, because if I try to create a sketch here, right, that's on the back of this part. It's not spaced out the front. All this stuff, right? So one good way to do this, when you define your sketch, you need to pick a plane, right? You have to have that plane there. So what you can just do is just create your own planes. Now, if I click this plane box, it's got some options in this drop-down list. There's several different ways to define planes. So I can offset a plane from basically another plane or other flat surface. I can create a plane that is parallel to a plane and passes through a point. I can create a plane on a line at a specific angle. There's some other ones. Mid plane is a useful one. I can create a plane off of 3 points, right? You might remember that from math class. Any 3 points in space create a plane. The ones that are super useful are offset and mid plane. Plane point is also pretty useful, and sometimes you'll use line angle. Actually, I would say line angle is actually probably more useful than plane point. We're just going to do offset though, because it's easy. And so we click a flat surface to offset from. And let's set the distance. You can click and drag, or you can type in what number you want. Let's like 2.5 inches or something, right? All right, so that's a plane, and then now I can create a sketch on this plane. Select the plane. I can hide the plane over here in the feature tree, because but when I have too many planes, it bothers me. They're kind of obnoxious. So as soon as I create the sketch, and I just hide the plane because I'm done with it. That's probably the only thing I'm going to be able to do with that plane. Now later, if you need to reference that plane, create another sketch on it, extrude up to that plane or something, right? You can go back to the feature tree and show it again. I'm gonna just gonna create kind of a little part here. We're gonna use it here in a second. Let's create a little L-shaped piece. And I don't know, throw some dimensions on this bad boy. Grab a equals constraint between these two lines, makes them the same length. Maybe dimension up here, it's 1 inch. Take an equals constraint between this line and that line, and that makes them equal length. And now you can see it's fully constrained. I only have 2 dimensions. I don't have to go and dimension everything. I want this leg and this leg to be the same height. So that means I want these 2 lines to be the same length. So I just use the constraint to do it. So it's super useful. All right, I'm going to extrude this out I don't know, 1/4 of an inch. It's like a little plate, basically. Yeah, and so let's talk about some more features here. So once you have a solid, right, like this is a solid, there's kind of some, I guess, there's some more features other than just extrude, right? We talked about extruding to make things. We talked about extruding to cut things. There's some other ways to just modify geometry kind of in place. So one thing that you're going to do a lot in a robot is you're going to have sharp corners, right? Like this, right? It's really easy to model these sharp corners with just lines. But in reality, on the final robot part, you really want these corners to be rounded. So let's talk about some ways to accomplish that. So first of all, let's go into our sketch, right, and edit the sketch. There is actually a way to take a corner and just round it in a sketch. So let's say we wanted to round this corner here. This feature right here, it's called a sketch fillet. Now it may look like fillet, but it's actually a separate word. It's pronounced fillet, and it's basically just a word for a rounded corner. Now a rounded corner can be an external rounded corner, like you can round this corner off, or it can be an internal rounded corner. And from the standpoint of a sketch or CAD, they're the same thing, right? An internal fillet and an external fillet they're the same thing, so they're combined into one tool. So what I can do is I can just click on this tool, and there's 2 ways to use this tool. I can either click the 2 lines that I want to fillet between, or I can click the corner point where they meet. So I can just click the corner point, and you can see here I can change the size of the fillet or edit the dimension, and then press enter. I can also, if I undo that real quick, I'm pressing Control Z on my keyboard to do that. I can also click multiple corners. and then, set the dimension to whatever and press enter. You'll notice some things broke here. So like this is unconstrained now, and that's to be expected because, because this line was here and it had an equals constraint with this line up here, but I cut off part of that line, and so it just got rid of some of the constraints that were on that line and replaced it with a new line, right? So the sketch fillet tool is kind of, I guess, destructive, right? It really kind of messes with your sketch, and most of the time that's bad. Every once in a while, doing a sketch fillet is a good idea, but I would usually recommend that you don't do it. The one cool thing about you know what I just did here with these multiple corners, aside from the damage that it did to my sketch, you'll notice if I hover over this, you'll notice there's an equals constraint here, right? Because I clicked multiple things before I typed in the dimension, it just automatically creates some equals constraints. I'm going to undo that though, because like I said, it's destructive. There's a better way to do it. I'm just going to finish the sketch. Everything's back to sharp corners. That's great. All right, so let's talk about how to, outside of a sketch, there's a way to do fillets. I go up here and there's a fillet tool. So I'll just click on the tool. Now, because this is kind of like a 3D fillet, whereas a sketch is a 2D fillet, instead of picking a point or two lines, I actually need to select an edge that I want to fillet. And so it's asking in this blue box, this blue box is highlighted, it's asking me to click on basically curved edges or square edges and to place a fillet there, basically to round that edge off. So that edge will go away and there'll be a round, smooth surface there in its place. There's some options here, tangent propagation, what's the measurement, all this stuff. You really don't have to mess with any of this stuff. Really what you only need to mess with is the radius, right? So we can type in like 0.125, which is like 1/8 of an inch. And then we can go to entities and we can click some edges here, right? And you'll see it kind of like creates a ghost of the original part here, and you can see the round. And then obviously it'll kind of finalize that once you exit the tool. So let's go through and let's select all the sharp corners here. Not the internal one though. We're going to leave that one. We want this one to be a bigger radius. I'll explain why in here in a second. But once we've selected the edges that we want, we'll click OK. And you can see the edges are nice and round. It's really good. This would be good for laser cutting or routing on the router or whatever. Okay, so then let's do this internal corner. Now, this internal corner, let's say this is a bracket and this is supporting something, right? This part, if you have a sharp corner in here, that creates what's called a stress riser. Basically, the part will want to tear where the sharp corner is. So on the internal corners of stuff, it's usually a very good idea to put a nice big round fillet there. Basically, the bigger the better. But typically you're limited on space, or maybe you're trying to save weight, so you don't want to fill all of this area with like the super giant fillet, right? Because like we go in and create a fillet here, and then just like drag this out and make this like super giant like fillet if we wanted to. But maybe for weight reasons we want to keep it a little smaller, 3/4 of an inch or something. I'm just hitting tab when I'm done here, by the way, to get out of this box. So let's talk about edge overflow. I think this is a good way to demonstrate this option. I haven't actually used this option, but let's uncheck this real quick and then let's drag this out. Nope, that does not work. Okay, maybe it's this one. I don't think it's this. I know what this option does. So. All right, I'm not 100% exactly sure what this is doing. Sorry, we're gonna move on. Like I said, I haven't used this option. There's a specific option that I'm looking for, but I'm not gonna waste time on it right now. It's super not important for this. Okay, so anyways, let's click OK. This part's done. All right, let's talk about the other one, the tangent propagation one, which I definitely know what that does. You can click like other edges that are like on the edge of a part, right? Because like this was kind of a corner, whereas like these edges around the rim of the part like kind of connect to other. Select I can select round edges if I want. Sorry about that. My audio cut out there for a second. All right, so we can select these round edges as well to create fillets. So I'm going to select this, and I'm gonna pick a like a smaller size here. If the size is too big, it like starts to intersect other things, and that's not what we want. So you'll notice the round edge is curved, right, which is great. That looks awesome. And it continues all the way around the part. You know, we've got this sharp corner here, so it's creating this sharp internal fillet. If you wanted this to kind of like nicely round off in a nice round way, you would have to fillet this edge first and then come in and fillet the whole part. And actually, I can demonstrate that. Let's exit out of that. Let's create a new fillet. Let's fill it here. Let's, I don't know, make that a little smaller, 0.25 or something. Actually, let's make it a little bigger, actually, now I'm thinking about it. This is going to be easier to show. I accidentally expanded that. I don't need variable. Just click OK. All right, so now we got this like nice, smooth, flowing shape. And if we go back and create the fillet here, you know, there's no sharp corner here anymore. Also, that's really big. So let's make this smaller. So now it's this nice smooth shape. So if you don't want those like sharp internal corners, like you got to fillet the sharp internal corner first and then go around and create the fillet on the top edge. Now let's say that for some reason, now this looks great, right? And most of the time this is what you would want. But let's say for some reason that you don't want all of this to be filleted all the way around. You want only the part that you selected, like only the edge you selected. That's what this tangent propagation option is for. Actually, so this is red because it's not building correctly. To be honest, I don't know why not. Let's go in and up to this box and delete this. Let's do a straight edge. That usually works better. Yeah. So there's kind of some weirdness about these rounded surfaces when you're doing this. You can do it, but in this particular case, it doesn't work. So you can create a fillet that just kind of cuts off the end of the part and doesn't continue around. I can try connecting this now. Yeah, it really doesn't like that geometry. This is probably a bad part to demonstrate this on. This is not really the case where you'd usually use it anyways, but this top edge is a pretty good demonstration, right? It just kind of cuts off the end of the part and doesn't continue into the edges that are tangent to it. So yeah, let's move on. We're gonna talk about one more feature here. Actually, we're gonna talk about one feature, and then we're gonna hit a little bonus thing real quick. So let's create a part studio. Go down here, hit the plus, hit create part studio. I don't know why I'm blind. I can't ever see it. So sometimes extrusions are not really a great way to create geometry. Sometimes you'll have geometry that's a little more complicated in a round shape, and you need a different set of tools to make that geometry. So we're going to talk about what's called a revolve. So we're going to create a sketch, same way we always do. Come on, let me select the plane. There we go. I'm going to hide all the planes like I always do. All right, so what we're going to do is we're going to create a round part, basically, except we're going to take a cross section of the part and we're going to kind of sweep it around an axis, like we were turning the part on a lathe or something, right? And it's going to create geometry in a circular way rather than an extrusion, right? It's kind of like a circular extrusion, basically. So let's just throw some lines in here. I'm not going to pay too much attention. The key thing is we need a line where the central axis of sweep is. So I'm gonna create a line here. I'm gonna do like a couple different, like, I don't know, complicated things. That's probably good. Throw some dimensions down. I don't know. Just dimension some of this stuff. Just doesn't matter what any of this is. I'm just gonna, create some angles. I don't know if I've demonstrated angle dimensions yet or not, but if you dimension between two lines that are not parallel, it gives you an angle dimension. Probably should have covered that in the class, honestly, but there's just so many little things that can happen that there's not really time for everything. So play around with some of this stuff, like, play around with some more of the constraints. Like there's a midpoint constraint, there's symmetric constraints, there's parallel and perpendicular constraints. There's just a lot of stuff here that you can just it's pretty self-explanatory. Like parallel and perpendicular, like does exactly what you think it does. You click two lines, it'll make them parallel, or you click two lines, it'll make them perpendicular, or whatever, right? So just play around with that, and that'll kind of help you get familiar with this. Okay, let's finish the sketch. This is just kind of this random shape. Now what we're gonna do is we're gonna take this region, we're gonna sweep it around this axis here, and it's gonna make a round part. So let's demonstrate that. It's pretty straightforward. Revolve. We need to pick the region, and then we need to pick the axis. You'll notice, boom, round part. You can kind of see, you can still see the sketch in there, so you can kind of see how it's like a cross section of the part. Now I only modeled half of it. You don't need to model both sides. You only need to model one side. So that's kind of important. You can also see I created this line here, which created the hollow area. I could also create a hollow area all the way through the part. I still have to have a line to act as an axis, but I can still create a hollow part, right? As long as I've got some line in the sketch just kind of floating there, right? So generally speaking, you'll do a full revolution where you want it to go all the way around, but sometimes you don't. So there's an option for full. For one direction's the simplest thing to understand. You can kind of, type in an angle for how much you want to revolve. You can do, symmetric, where it's doing it on either side equally, or you can do two directions where you have two different sides that you can control angles independently. But most of the time, you'll just do, full. Create this part, and then from here, you can add sketches on planes and do extrusions and whatever you need to continue modeling the part. I could do a sketch here and create a polygon. This is a tool I didn't show, but it exists. You can figure it out yourself. It's a little bit weird. You got to click twice if you want it to be. It defaults to a hex. I think just dimension crossed here, half inch. Maybe extrude that out. Right. So you just continue modeling and everything's great. So okay. So that's the revolution. You can also revolve cut. If I go back here and edit this real quick just to show, you can create new geometry, you can add geometry, you can remove geometry, remove just cuts. You've got the merge scope. It's exactly like an extrusion in terms of how the merge scope works. So if you don't remember that, go back and watch last week's video. I explain all of that. It's the same for revolve as it is for extrude. Okay, let's talk about one quick bonus thing here. We got a couple minutes. Let's go back to our first part studio over here. And actually, let's name this. Let's right-click on this part studio and click rename. It's a good idea to rename your part studios. If you're on the RoboChargers and you're working on Robot CAD, I expect you guys to name part studios. I don't want to see, part studio 2, part studio 3, and have to click through and figure out what they are. I want something descriptive here. It's going to help all of the mentors and all of your teammates and everything understand what's going on, who's working on what the team's working on, what's done, etc. Find files for manufacturing. It's a good idea to name these. So I'm just going to name these by the features we were teaching. Okay. Now, if on this part here, right, if we go back into our feature tree, we can edit these fillets here. You can hover over them and see which ones are which. This one's our little corners. This one's our internal feature. There's also this little rectangular bar here. Kind of hard to see. It shows up at the bottom. It's called the rollback bar. The rollback bar. And so I can pull this up, and it kind of temporarily gets rid of the features. And as you can see, they all disappear. All the fillets disappear. And if I drag the bar down, it kind of slowly steps forward through the features. This is super useful. It's useful for two things. First of all, if you want to roll back to an earlier state, to only see what your part was like in the early stages, that is useful. Like if I want to edit, if this part is very complicated, it will take a while to recalculate. So if I change some early feature and it has to recalculate the whole part, that could take a very long time. It could take, 10 seconds or something, right? Could take a minute if it's something really complicated. And so if I'm editing a really complicated part and I want to save myself some time, I'm editing an early feature and I want to just edit the feature, exit out of the feature, look at what the part looks like, go back into the feature, edit again, right? I should roll the rollback bar up to kind of like a farther earlier state in the part, so it's only rebuilding it a little bit at a time, as I'm editing the sketch. And then once I'm happy with like the sketch or the feature, whatever it is that I'm changing, I can take the rollback bar and you right click on it and hit roll to end, right? Or just drag it all the way down. Dragging it all the way down is kind of obnoxious for like really long feature trees where you get this big long scroll bar. But so roll to end is super useful. All right, so that's not actually what I wanted to talk about though. I just want to roll past these fillets, so we're focusing on this part here. Basically, if you're adding all these corner features, right, you have to click on these like one at a time, which is super annoying, right? If you've got a part that has like a lot of like holes or something that you want to fill at all the edges, this takes a long while. So there's a feature script that helps us with that. So we're actually going to delete this fillet. If we right click on it and hit delete, the fillets go away. It removes that item from our feature tree. So then whenever I add a new feature, when I'm in this rolled back state, it will add it where the rollback bar is. And so this is the other use of the rollback bar, which is I can insert features anywhere in the history of my feature tree. Now you have to be careful doing this because if you do it wrong, right, you'll introduce errors into your part, and you'll have to go figure out. You can fix those errors. All the errors are usually fixable, but it can be a lot of work to go in there and like delete constraints out of sketches and replace references for extrusions and whatever. Right, there's like a lot of work to repair the feature tree if you break it, right? So we're going to use a different feature to add all these corner fillets that just takes one click. So we're going to go into our feature tree drop down here, and it is called Fillet All Edges, which does pretty much what you would expect. You click a face, and it will fillet all the edges, all the sharp edges that are perpendicular to that face. And you just type in the radius, right? 0.125, tab, or hit OK. Now you can also exclude edges. So we're gonna talk about two ways to do this. So if there's an edge that you don't want in there, you can just click in the box to highlight it and then select the edge, and it won't fillet that edge, right? That's pretty straightforward. Now there's another way to do it too. You can kind of do it by the order of your feature tree. So if we go down here, we want to fillet this internal corner. We don't want it to be 0.125. We want it to be something else, right? So I could go into the fillet all edges, and then select this one to have it avoid that. I'm actually going to remove this fillet here because I actually want that edge rounded. So I'm going to click OK. However, there's a slightly cleaner way to do it. You should do, if you've got like fillets that are super internal for functional reasons, like we said, we added that fillet for strength, right? That's more important than these outside fillets. These outside fillets are really just to make the part look nicer and not have any sharp edges to cut yourself on, whereas this fillet in the middle, right, might be functional, right? So it's typically a good idea to do all your functional stuff first and then do your aesthetic stuff later. So we're going to kind of demonstrate that, and I'll get more into this as we get into more complicated projects, but like the order that you do stuff in the feature tree is pretty important for keeping things nice and neat. So what I'm actually going to do is I'm going to click and drag this fillet up above the fillet all edges feature, and it reorders them. And you'll notice the error goes away, like that little like red icon and whatever, all that goes away. So if I roll my bar up above the fillet all edges, these fillets go away. This fillet's here, right, which is the same as it was before. And then if I roll back down below fillet all edges, these edges show up. And so if I edit this feature, this face is selected. And basically what happened was there was a sharp edge here, but now that sharp edge is gone because we have a fillet there, right? Because we reordered the features. The fillet comes before the fillet all edges. And so basically that sharp edge is gone, so it doesn't put a fillet there because there's already a fillet there, right? It works basically if there's no sharp edge there, it doesn't put a fillet there. So if you put a fillet on that edge before the fillet all edges feature, you don't have to deal with like excluding edges and stuff, right? The exclusion is like useful, but you should try to avoid it if you can, because there's usually a cleaner way to solve that problem. But like if you've got some edge of your part that you just don't want fillets on, like let's say we want this to be a sharp corner for some reason. That is, if you just want the corner to stay sharp, that's the case where you use the exclude. Okay, so that is all we've got for this week. We're getting wrapped up in the part environment. We're gonna do a little bit more next week, and then we're gonna move on to some more complicated things. So thanks for watching. I will see you guys next week.